Suppose we take an example of a compound glucose which has molecular formula C6H12O6. So what empirical formula is? Empirical formula is the formula of a compound which shows the simplest whole number ratio between atoms of the element in the compound. The simplest ratio of whole numbers between atoms of the element in the compound would be 1:2:1. So how you can write empirical formula for glucose? CH2O, right? Similarly, if you take another example of benzene which has molecular formula C6H6, it would have the simplest ratio of whole numbers as 1:1. So you could write empirical formula for benzene as CH. Now see, the empirical formula does not indicate the actual number of atoms, does not indicate the actual number of atoms present in the element, right? In the compound, but it shows the simplest ratio. Let's determine the empirical formula of a compound. To determine the empirical formula of a compound of sodium, sulfur and oxygen having percentage composition sodium 29.11%, sulfur 40.51%, oxygen 30.38%. Now you all know the atomic weight of these elements. Sodium, we know atomic weight is 23. For sulfur, atomic weight is 32. Oxygen's atomic weight is 16. Now what we have to do is, step 1, you will write down the percentage composition or weight and the atomic weight of each element present in the given compound. For example, element sodium has percentage composition 29.11 and its atomic weight is 23. Sodium, then sulfur has percentage composition 40.51. This is the percentage composition. This is the atomic weight. Sulfur's atomic weight is 32. Oxygen, we have percentage composition of 30.38 and the atomic weight of oxygen is 16. Now the next step, what you will do is, you will divide the percentage composition of each element by its atomic weight. The ratio gives the number of atoms of each element or relative number of atoms in the compound. For example, let's see the element sodium. Sodium has percentage composition 29.11 and atomic weight is 23. Now how you will find the relative number of atoms? What we will do is, we will divide the percentage composition of each element by its atomic weight. So what you will do is 29.11 divided by 23, which is 1.266. Now relative number of atoms in sulfur, 40.51 divided by 32, which gives 1.266 again. Next is for oxygen, 30.38 upon 16, which gives 1.898. Now till now this is the second step which we followed. we took out the relative number of atoms in each element. Now step 3, what you are going to do is you will select the smallest ratio or number, that is a quotient, among the relative number of atoms and divide the remaining ratios by it to give the simplest ratio of atoms present in the compound. For example, the smallest ratio amongst these is 1.266, right? If the simplest ratio is not a whole number ratio, multiply each ratio by the smallest suitable integer. What you will do is you will multiply it by smallest suitable integer so that a whole number ratio is obtained. So what you will do is, for example, 1.266, 1.266, 1.898, these are the ratios. What you will do it, you will convert it into simplest ratio. And what I have told is that if the simplest ratio is not a whole number, you will multiply each ratio by smallest suitable integer so that a whole number ratio is obtained. So what you will do is you will multiply here 1 into 2 equal to 2. 1 into 2 equal to 2. Here and here you will take 1.5 into 2 equal to 3. So the simplest ratio of whole number is 2 is to 2 is to 3. Hence the empirical formula would be Na2S2O3. This is the empirical formula. Now let's solve a problem based on empirical formula. A compound of carbon, hydrogen and oxygen is found to contain 40% of carbon, 6.7% of hydrogen and 5.3% of oxygen. You have to calculate its empirical formula. So with the method I showed you all, you will first write down the name of the element. You will then write down its percentage composition. Third, you will write down its atomic weight. Then you will find out its relative number of atoms. The next step, you will take out the simplest ratio of whole numbers. Now write down the elements. First is carbon. The percentage composition of carbon is given 40%. Atomic weight of carbon is 12. The relative number of atoms would be 40 upon 12 equal to 3.33. Next you will take hydrogen. Hydrogen has percentage composition of 6.70%. The atomic weight of hydrogen is 1. You will take out the relative number of atoms, 6.70 divided by 1, which would be 6.70. The next is oxygen. Oxygen has percentage composition of 53.3%. The atomic weight of oxygen is 16. The relative number of atoms for oxygen would be 53.3 divided by 16, which would be 3.33 again. Now you will convert these relative number of atoms into simplest ratio of whole numbers. What you will do is you will divide by the smallest relative number of atom. The smallest relative number of atom comes out to be 3.33. So what you will do, you will divide 3.33 upon 3.33 in order to convert into smallest whole number ratio or simplest ratio. It would come out to be 1. 6.70 divided by 3.33 would be 2. 3.33 upon 3.33 equal to 1. Now see, hence the empirical formula of the compound would be, you'll write down the elements first of all, CHO, and then you'll write down the simplest whole number ratios besides them. So the empirical formula comes out to be CH2O. So what is the empirical formula? Empirical formula is the formula of compound which shows the simplest whole number ratio between atoms of the elements in the compound, and it does not indicate the actual number of atoms of the element in the compound but their simplest ratio. Now, in a question where you are being asked to state the empirical formula of each compound whose molecular formula is C5H10, how you'll take out the simplest whole number ratio? The ratio of C and H is 5:10. The simplest ratio would be 1:2. So the empirical formula would be CH2. Here, on the other hand, you have to find out the empirical formula for H2CO2. Ratio you will take out first of H, C and O, which would be 2:1:2. This is the ratio of the compound. Now, so the empirical formula for here would be the same. It would be the same because this is itself the simplest ratio, और इससे ज़्यादा simple नहीं हो सकता. H2CO2. This is the